Hello, today in this video we'll be discussing left recursion which comes under the context grammar. It is a very important topic which gives some problems whenever the suppose left recursion is a major problem which is not suitable to construct a correct push down automata. That's the reason you need to eliminate the left recursion. In this, we will be understanding what is left recursion and how to eliminate the left recursion. There is some procedure will be there. Then we'll see some of the problems. Okay. So first we'll see what is a left recursion. A grammar is said to be left recursive if it has a non-terminal a such that there is a derivation a gives a alpha for some string alpha. Let us understand what is the definition of this left recursive. Try to understand any grammar and right hand side and left hand side start with a same non-terminal symbol, then such grammar is having a left recursive. Okay, so then see how to eliminate left recursion for the given grammar. So then some procedure will be there. The first step is arrange the non-terminal in some order. A gives A1, A2, etc. An. This way you can arrange it. Then start eliminating. So consider a production of the form. Any production is in the form of A gives A alpha 1, A alpha 2, A alpha 3, A alpha 4, etc. A alpha n and beta 1, beta 2, beta 3, etc. beta n. Any production is in the form of like this. You have to try to convert like this. So where alpha n do not start with a production, then a production can be replaced by this a production can replace by a gives beta 1 a dash, beta 2 a dash, beta 3 a dash, beta 4 a dash, etc. beta n a dash. Then we have introduced one variable a dash. Then what will be the a dash? A dash will be alpha 1 a dash, alpha 2 a dash, like that, etc. alpha n a dash or epsilon. So any production, I will be recalling again, any production is in the form of a alpha n, a alpha 1, a alpha 2, etc. a alpha n, beta 1, beta 2, beta 3, etc. in this format. Then you have to convert in these two format. A production can be start like this, beta 1 a dash, beta 2 a dash, etc. beta n a dash. Then what will be the a dash? A dash will be alpha 1 a dash, alpha 2 a dash, alpha 3 a dash, etc. epsilon. So this will be the step you have to eliminate the left recursion. Then left recursion, so I will be shorten it. It is easy to understand, easy to remember it for a longer period. So previous slide I have given depth of the step to remember it. Here it has shorten it. Suppose any production A gives alpha I. Suppose left and right hand side start with the same non-terminal symbol. Then alpha I means 0 to n. Then beta I. So alpha I or beta I. So beta I means 0 to n. So it can be write it like this. So A gives beta I, then a dash. A dash will be alpha a dash or epsilon. So we can easily remember any production is in the form of a alpha dash. A gives a alpha or beta, then again a production will be A gives beta a dash, beta I A dash gives alpha I, A dash, then epsilon. If you remember, it can easy to eliminate the left recursion. Let us see the first example how to eliminate the left recursion. Suppose you take this example, E gives E plus T or T. These two are having a left recursion because left hand side and right hand side start with the same non-terminal symbols. Look at this. This is E, this also E, then it is having a left recursion. We need to eliminate it. Then have to apply that procedure which we have discussed in the previous slide. Look at this. First, that is A. So A is nothing but here E. So then what is beta here? T. Then what will be the A dash? A dash is nothing but E dash. Then E dash. Then what is a E dash? E dash gives alpha. Here it is. This will be the A alpha. So alpha, that is alpha is plus T. Then E dash. Then what is that? Next it is R epsilon. So this will be the similar to the previous. Now nothing is start with the same non-terminal symbol. E gives T dash, E dash gives plus T E dash R epsilon. Okay. Then what about the next this one? So next grammar is also having a left recursion. Left hand side and right hand start with the same non-terminal symbol. Then I can apply similar to the first one. So then what is a T? T gives T gives ft dash. Here it is beta is F. Then you have to T dash. Then what is a T dash? Then T dash is what is alpha? Star ft dash or epsilon. So then we have seen the first production also having a left recursion, second also a left recursion, you have eliminated. Then you can see, now you can understand how to remove the left recursion for third grammar. Here also having a left recursion since it is start with the first left and right hand side with same non-terminal symbol. Then x is equal to, here it is a beta is z, x dash gives percentage y, x dash or epsilon. Yeah guys, we will see some more example. That is example 2. Left recursion. There is an example like this. S gives A or B. A or B. There is A gives AC or SD or epsilon. In this example, if I see the grammar, having left recursion is only A production. So if I check thoroughly, so even S having a left recursion indirectly. How this help is seeing, right? So left recursion, suppose S can be replaced by A production. So similarly, that is, if I remove this, how it will becomes like this. A gives AC and A gives ST. S can be replaced by S production in A production. Like this, A D or BD. Okay. Then these two production can be write it like this. A gives AC or AID or BD or epsilon. So altogether it becomes like this. S gives A or B. A gives AC or AD or BD or epsilon. Then how do you eliminate this? Now you have to eliminate like this. You have to apply those rules. Okay, so first of all, the S production is not having a left recursion since you have removed the indirect left recursion of the S. Then A production, in this case, there are beta 1, beta 2 here. Beta 1 is BD and beta 2 is epsilon. So BD A dash beta 1. So then beta 2 is epsilon. Epsilon is, if you write here epsilon right or not, it is understood there is an epsilon. So A dash. Then what is alpha 1? C a dash, alpha 2 is AD, small AD, alpha 1 is alpha 2 AD, A dash or epsilon. So this will be the answer after eliminating the left recursion of example 2. So, and also you can see some of the exercise problem. You guys please have to practice these two problems, and while doing other example I have discussed it in this. Apply the similar formula, you can eliminate them. So we will get the more concise example understanding and clear your doubts. Do you still have any problems? Please have to share it in the comment box. I will give a clear example, or else I will give this problem in a short file in the next video. If you wanted to some more example on this topic. Thank you.